In late 2019, astronomers detected something that should not have existed. It appeared in the southern sky in the constellation Grus, moving so fast that at first the measurements were dismissed as an error. Instruments were checked. Data was recalibrated. Observations were repeated. The numbers did not change. The object, later designated S5HVS1, was traveling at a velocity of approximately 1,755 kilometers per second, nearly 4 million miles per hour, or about 6% the speed of light. That speed is not just unusual, it is extreme. At that velocity, an object inside our solar system could travel from Earth to the Moon in under 4 minutes. It could cross the distance from Earth to Mars at their closest alignment in less than 9 hours. A journey that takes human spacecraft 6 to 9 months would be reduced to a single afternoon. No known natural stellar process was expected to produce motion like this. And yet, the measurements were correct. S5HVS1 is not alone. It belongs to a rare but growing class of objects known as hypervelocity stars. Stars moving so fast that they are not merely escaping their local stellar neighborhoods, but breaking free from the gravitational grip of entire galaxies. These are not interstellar travelers. They are intergalactic escapees. At such speeds, nothing inside a normal stellar system can hold them. No star, no cluster, not even a galaxy the size of the Milky Way. Naturally, astronomers searched for a powerful explanation, and they found one, at least in theory. At the center of most large galaxies lies a supermassive black hole, millions or even billions of times more massive than the Sun. When a binary star system, two stars orbiting each other, passes close to such a black hole, gravitational forces can tear the pair apart. One star falls inward, the other is flung outward at enormous speed. This mechanism, known as the Hill's mechanism, is well understood in principle. It can accelerate stars to thousands of kilometers per second. It explains how hypervelocity stars can exist. But theory only works if the observations cooperate, and increasingly, they do not. When astronomers mapped the trajectories of known hypervelocity stars, they expected most of them to trace back to the galactic center, home of the Milky Way's supermassive black hole. Instead, only a small minority did. Out of more than 20 hypervelocity stars identified in the outskirts of the galaxy, only 2 could be clearly linked to the galactic core. A larger number appeared to originate from an entirely different region of space, near the Large Magellanic Cloud, a dwarf satellite galaxy orbiting the Milky Way. This posed a serious problem. The Large Magellanic Cloud does not show evidence of hosting a supermassive black hole. Despite extensive searches, no accretion disk, no high-energy radiation, no gravitational signature consistent with such an object has been detected. And yet, hypervelocity stars seem to be emerging from its direction. Worse still, some hypervelocity stars appear to originate from regions with no plausible black hole source at all. This is not a minor inconsistency. It directly challenges the dominant model explaining how these stars acquire their extraordinary speeds. The problem deepens when we examine intergalactic starlight. Astronomers studying galaxy clusters have discovered that roughly 15% of the visible starlight does not belong to any galaxy. These stars drift freely between galaxies. This is surprising. Stars require dense clouds of gas to form, conditions that do not exist in intergalactic space. Therefore, these stars must have formed inside galaxies and been ejected later. If supermassive black holes were responsible for ejecting these stars over time, older galaxy clusters should contain significantly more intergalactic stars than younger ones. They do not. The percentage remains nearly constant across clusters of different ages. This suggests that stars have been moving between galaxies continuously, not gradually accumulating over cosmic time through rare events. Once again, the natural explanation struggles. At this point, astronomers invoke secondary mechanisms. Supernova explosions in tight binary systems, gravitational interactions within dense star clusters, or unknown massive objects yet to be detected. Some of these explanations may apply in specific cases, but none explain all of them, which leaves an uncomfortable question hanging in the background. Could some hypervelocity stars be artificially accelerated? This idea is rarely discussed in mainstream astronomy, not because it violates physics, but because it violates expectations. The notion that an advanced civilization could manipulate stellar scale objects seems absurd at first glance. But when examined carefully, it is not forbidden by known physical laws. In fact, it has been studied quietly for decades. The concept is known as a stellar engine. One proposed design involves placing a massive structure near a star to harvest and redirect stellar energy. By ejecting ionized stellar material in a controlled direction, such an engine could produce continuous thrust. The acceleration would be tiny, billions of times weaker than Earth's gravity. But stars live for billions of years. Over millions of years, even a minuscule thrust could accelerate a star to thousands of kilometers per second. More advanced concepts improve efficiency by combining mass lifting with gravitational coupling, allowing a civilization to pull a star rather than push it. These systems could theoretically accelerate a star to relativistic speeds, carrying its planets, asteroids, and potentially life along with it. Why would anyone do this? Because moving a star is the ultimate solution to interstellar travel. Instead of sending ships between stars, you bring the star with you. A civilization could relocate an entire solar system, avoiding cosmic threats, seeking resources, or migrating toward favorable regions of the galaxy. This is not science fiction. It is speculative engineering, but grounded in physics. And intriguingly, some hypervelocity stars exhibit behaviors that are difficult to reconcile with natural ejection. At least one hypervelocity star has been observed retaining a planet. This should not happen. A close encounter with a supermassive black hole would strip planets away through tidal forces. A star ejected naturally should not carry companions. Yet one appears to. Closer to home, Barnard's star, one of the nearest stellar systems to Earth, exhibits unusual motion. While not technically hypervelocity, it is moving much faster than neighboring stars. It also displays unexplained activity inconsistent with its age, including powerful flares that should not occur in an old red dwarf. Barnard's star shows a subtle wobble, suggesting something massive in orbit, but repeated planet detections have failed to fully explain it. None of this proves artificial intervention, but it keeps the question open. Science advances by exploring all plausible explanations, not only the comfortable ones. At present, the hypervelocity star phenomenon remains partially explained, partially mysterious. Natural mechanisms clearly operate, but they do not account for everything we observe. If even one hypervelocity star were confirmed to be artificially accelerated, it would represent one of the most profound discoveries in human history, not proof of visiting spacecraft, but proof of stellar scale engineering. Proof that intelligence elsewhere in the universe has learned to manipulate nature on a level we are only beginning to imagine. And yet, this possibility is largely ignored, not because it is impossible, but because it is disruptive. It challenges deeply held assumptions about humanity's place in the cosmic hierarchy. The universe may not just be vast. It may be inhabited by civilizations that think in units of stars and galaxies. For now, the mystery remains unresolved. Hypervelocity stars continue to streak through the Milky Way, silent and indifferent, on trajectories that will carry them into the darkness between galaxies. Whether they are the product of violent gravity, rare cosmic accidents, or something more deliberate is still unknown. But one thing is clear. The universe is capable of far more than we once believed. And it may be time to expand not just our instruments, but our imagination.